Well, again, we're working with systems with 3 variables. We did linear systems before, and that's pretty easy. You can do that with elimination, substitution, or graphing. Elimination, substitution tend to be difficult when we work with 3 variables. This one is very easy, actually, and that's why I just put this up here. But you'll have examples of no solutions or infinite solutions, and basically it's just this. Infinite means it's just the same equation on top of each other. Whereas like no solution can be actually 3 different cases. It can be like 3 planes stacked but not directly on top of each other, or it could be a triangle of 3 planes formed, or it could be even 2 crossing and 1 crossing somewhere else. So it's kind of arbitrary to go over all those types of examples. That's why we use matrices instead. And that's where you really get into the fundamentals of matrices. And I put up some videos with Kramer's rule and the determinant and all that good stuff. So hopefully that will help. But basically, just to give you some sort of picture here, this is a 3-dimensional plane where x is this slanted axis, and y is this axis, and z is the up and down axis. And you can actually graph something pretty cool, and it kind of looks 3-dimensional if you use your imagination. Try graphing it yourself and plotting points if you're an artist especially. You'll do it better than I did. Anyways, I don't want to keep going with that. What I want to do is I want to solve. I want to figure out what x is, I want to figure out what y is, and I want to figure out what z is. Now what you do is you look at the equation that is most suitable for you to solve, and you can use substitution or elimination. Most problems tend to be more difficult than this. This happens to be a very easy one. In this case, the first variable you should solve for is z, because z is already by itself. 3z equals 21. So I have that. Divide by 3, and you're going to get the value for z. Z equals 7. Now using that information, you know z equals 7, and we already used this one. Check. No problem. I'm going to use one of these 2 to figure out what either my x or my y is, and that means, oh, let's use this one because I know this is 7, so all I got to do is subtract and then divide. So that's what I'm going to do. 4x plus z equals 19, but z is 7, which coincidentally I seem to write very similarly. When I do all that work, I get x equals 3. So now I figured out what my z value is, I figured out what my x value is. Let's use it to figure out what my y value is. I got 2x subtract y equals 2. 2 is 2 times 3. Subtract 6 on both sides. Negative y equals 2 subtract 6, which is negative 4. Hopefully I did that right. Yep. And divide by negative 1. It's about to put negative 1, because there's a negative 1 in front of the y. Y equals 4. That's my answer. It's x equals 3. Y equals 4. Z equals 7. And then you go ahead and you plot. You go, well, this would be negative, so this is positive, 3 this way. And you go 4 on the y, and you go 7 on the z. To be honest, I don't know how far. It would look something like this. Something like that. I have to practice graphing my 3-dimensional plots. I know that you go 3 on the x and then 4 on the y, but you don't go all the way here because you're already shifted a little bit over, so it'd be something like this. And then you got to go 7 on the z, but you're already down here. So, like, technically speaking, you should be like right there. It's a little confusing to explain, and I wasn't ever really that great at it, but I'm sure I could figure it out if I just plotted some 3-dimensional aspects once in a while. Anyways, enough of that tangent. I hope that was helpful. That's a very easy example. Most aren't, and usually what you use is matrices if you want to do systems with 3 variables. Other than that, have a great day. Bye.